We're learning Rust by example, and the next thing that we're going to check out are enums, or enumerations. These enumerations are essentially variants. They allow you to define sort of a state, something that you can use that associates with like an occurrence, and of which there can be a number of occurrences, like an event, and you usually typically only have one of them, and they're in a set, sort of like a one thing at a time. So it allows you to define a list of items of possibilities, and these possibilities of which typically one there's going to be an instance of. And so they can be like states, like maybe if you're defining a person, like if you're doing a struct, you can have a whole bunch of parameters of a person, like their name or their age. With an enumeration, you can have sort of what action are they currently performing. They could be running, they could be jumping, they could be laying down, and typically they're only going to be one of those things. And so that's what enumerations are. They're a way to sort of capture the idea of a whole bunch of possibilities. They're all related, and typically only one of those items is going to be part of the picture. So we've defined here sort of a computer interaction, a web event. We've defined an enum, a web event, and the page could be loaded, it could be unloaded, there could be a key press occurring, someone clicked the paste button, someone clicked in a location. This is what's really powerful about Rust enums, is that in addition to providing a variant or a definition of it, you can also have associated data that can be captured with the event. This is really powerful. I really like this. When you're running through flow control to decide based on the event that occurred, you can capture the event and then perform actions based on what that event is. So like say if the page is loaded, you can like have a loading indicator say completed, like a checkbox or something like that. If it's the page is unloaded, then you could say all is done or something. But here's really, it really gets really awesome. So the key press enumeration, you can have a variable that defines what key is actually pressed. So the key press event occurred with a variable, and then you can say which key press it was. Same with like a pointer gesture or a mouse click. You can define a click with an X and Y coordinate of where the user clicked on the screen. And then you can use that information like in a game to update a player sprite. You can use that information to figure out where the user clicked on a web form or UI, so that way you can perform a specific action that's related to where that click was landing. Wait, hold on. What is this inspect business? Wait. Oh, okay. I thought we were getting a new special Rust capability. No, this is just the function that we've defined. Okay, so we've got a function here that we've defined that's expecting a web event, an enum, with the name of variable of event. Based on the event, we perform specific actions. And so what we've done here is we've created a whole bunch of events, and then we're running it through our function, our inspect function. And so we've pressed the X key, we pasted some text here, my text, we clicked at 20 by 80, we loaded and then we unloaded the page. So if we click the play button, we see that we pressed the X button because in our inspect, we say pressed the variable, the character, or the key in that case. I think that it should be, say key would be a better variable name. We pressed the X, then we clicked at 2020. Oh, we pasted some text in there. So this is really powerful construct for organizing your code. This is a foundational aspect to Rust and defining how your code is going to be organized with an enum and also a struct. These are the two most prevalent, most powerful, meaningful ways to organize your code in a file. I wanted to check this out. So one of the other things you can do with enums and structs, you should be able to have enums that have enums, right? You can have an enum inside of an enum. I want to play with this really quick. Let's define enum custom. So let's have a custom enum here called custom, and then something happened. Okay, we've defined that. I should be able to define, can I? I think you can. We could say page has a custom of happened again. I wonder how, okay. So we might have to, so we have our enum custom happened again, something happened again. Page load, I just attached it to here to see if we can use that inside of the web event because it's a variant of a variant. And then U8, unsigned 8 integer, so a value between 0 and 255. And I should be able to get that value here. And I'm kind of curious. Oh, wait. Let's see here. For the loaded event, I also need to define a happened again of 12, just some random. How about 42? There we go. I like that one. And then we should be able to define capture our variable, our enumeration definition here. Let's see what happens. I might have to do a little bit of extra. Yes, I need to show what it looks like to print. Okay, added in here the debug print with the pretty, and then I have to define this as derived debug because the compiler is actually pretty useful in this cases. I have to put this here. It's like, hey, put this right there. And then we should be able to click play. And is it going to work this time? We'll see if it works. Yes, it worked. Okay, then so check it out. So the page loaded with a value of 42 for the happened again enumeration. So this is really cool. I like this because now I can have enums defined, but I can also capture enums inside of enums and then use the enumeration. So you can have all these sub enumerations. So this is a great way sort of to define the logic and structure of your code using enumerations. It's really powerful. And then you can capture the possible flows that define the enumerations. And then Rust, with its really strict type checking, will mandate that you've covered all the use cases and all the potential values here. So if, like, for example, if I were to omit this, I should get a compiler error because it says, hey, you didn't cover that case. Because I've defined it in my enumeration, but I don't have any code to cover it. So here you go, not covered. And then it gives you an example. Oh, cool, there's a to-do thing. Hold the phone. We're gonna try that really quick and see what that does. All right, so we've had page load with an underscore, which just means ignore it. It's a variable. It's gonna be a variable. The underscore is there, but we're not gonna use it. So it's just unused, essentially. Anything that starts with an underscore, the compiler will ignore that it is not being used, even though it is there. So it's like a throwaway, right? You don't usually want to see this, but it is a nice little gotcha. And there's this to-do. What is going to happen when I click this button? All right, we got it under to-do. Well, I ran into some sort of thread panic, even though it does continue onward when I run this in a compiler locally. It doesn't seem to have a problem. However, this to-do thing in the web compiler here seems to have some issues. Regardless, if I don't use that to-do and I go about business as usual and actually leverage the variable passed into it, everything works fine without any thread panicking. And there we go. It's going to be perfect. Okay. It could be old compiler in the Rust by example, could be something along those lines. Just make sure your compiler is up to date. Another neat way to help organize your code is something called a type alias, where you've defined varieties of structures and enums. You can also just sort of rename those without having to do a lot of code replacement to make a cleaner code file. So you'd be able to sort of alias a type of some sort. So for example, you've got a very long verbose enumeration, and it could be justified to have something that long. Usually not. You usually want to have like 1 word or 2 words max when you're defining variables to be concise about your definitions. So like operations, there we go. That's a much better. So you could simply just say type operations equals the very long very verbose enum of thing to do with numbers. And then you can leverage this type alias, which is our operations, right? Because we have some operations here in enumerate. We're going to have an addition or a subtraction. You could also have multiplication, division, right? And so those would be our operations. And then you can match on those operations. You could also define operations. So it's just an enumeration. In like other programming language, enums typically are also assigned to a numerical value, right? So you'd have a large list of variable names that are all defined like 0, 1, 2, 3, 4, 5, 6, 7. In Rust, you just have the name itself, which I think is a nice improvement and simplification. So with aliases, we have the ability just to simply one-liner, just type our alias name and then we assign it. Very simple, very easy. And this helps us when we're taking advantage of any abstractions or other code constructs like enums from other libraries. We can simplify those and create a little simplified type alias. And it can also help us define what specific things we are looking to take advantage of with that enumeration. We can use a word sort of that just helps organize our code a little bit better. Another alias that is common, like automatic and for free, is the self alias. The self alias is simply referring to whatever is the current scope of what is being acted upon in, for example, when you're defining logic or functions that are encapsulated inside of your enum or struct. So we have an enum here that's a very verbose, long-named enumeration. Instead of having to type this out every single time like this, which is really, verbose, you can just simply refer to self because we already know that we're currently acting on this enumeration when we're defining a function that's going to be attached to it. So it's really nice to have self here in that case, as it's a for free type alias that comes with every single definition. Also notice here that we have a variable name that's called self. You can name this whatever you want. It's essentially a reference to the current instance of the enumeration. So we have an instantiate enumeration, probably like x equals operation, and then you could run x dot add, and then you have two variables or two values here. And so it checks to see what the self is, that current instance, and self would be add in this case. So you'd supply those two variables and then they would add, and that would be the value that gets returned. So we should be able to do it like this. And then we have x.add, or run in this case, because we have the operator, and we have 1 and 2. We should be, and then we can print that. And then we run it, we see the output is 3. So we have our operation, which is add, it's enumeration, and then we have a function that we can say sort of like execute the operation, right? We see that our self is add, so we'll add those together because we've defined our x variable as an add operator. And we run the operator, and then our output is 3, because 1 plus 2 is 3.